This is Mr. Anderson for Kellogg Community College. We'll be doing the start of Chapter 7, Section 1 in Math 121 Intermediate Algebra, Radical Expressions and Functions. First of all, we're going to talk about the square root rule. When we take the square root, a lot of us, when we type this in, we get an answer of just 5. But did you know that that's not the only answer we can get with the square root? Technically, when we take the square root of a number, there's actually two roots. There's -5 or +5. When you take two numbers to multiply to make 25, you can either have two negatives to multiply to make that, or two positives to multiply to make that. So for example, in number 1, to find the square roots of each number, we're going to have -9 and +9. Or we could have, to take the square root of this on your calculator, you would have either -50 or +50. Now your calculator is only going to have one of those two answers. It's only going to have the positive answer because the calculator assumes that no radicands were formed by raising negative quantities to even powers. So when you take the square root of anything on your calculator, it will always give you the positive answer or the absolute value of that answer. So this little clause right here is going to get us out of writing absolute value symbols. So let's do some simplification. If we take the square root of 64, we'll get an answer of 8. But you'll notice that the negative sign is on the outside of the square root. So even though we took the square root of 64 to give us 8, the negative is just sitting out there ready to be put in front. So there it is. And another little property of square roots is that you can take the square root and break it up into two smaller roots, or at least smaller root symbols, one for the numerator, one for the denominator. This will be very useful for us in the future. So we can take the square root of the 16 independently and the square root of 49 independently, which is pretty nice. Okay, now moving on to the next part here. We're going to do some substitution. And what we'll do is plug the number in for x, 0, -1, and -10, do some computing, and then do the work and try to see if we can, see what we get here. So I'm going to plug 0 in for my x, so that my t of 0, sorry, that t looks like an a there, my cursive t, 0 is equal to -0 squared plus 1, or negative 0 squared is 0 plus 1 is 1, or -1. So now I'm going to plug in my -1 here. So I'm going to have negative square root. Now this is a -1 squared, which means that this will get squared out. So -1 times -1 is +1. So I have +1 plus 1. So this is negative square root of 2. If I plug in my t, -1, and that's plugging my -1 in for x. Now I'm going to plug in -10 for x, so I'm going to go t -10. That's equal to the square root, and I've got -10 quantities squared plus 1. So this is going to be -10 to the second power is going to be 100 plus 1, which is the square root of 101. So t plugging in my -10 in for x gives me the square root of 101. And you can type that into your calculator and get a decimal. All right, now let's do some substitution here. What happens here, now check out some of the weirdness that happens in this problem here, because all of these were positive numbers inside of the square root, but the fourth root has some of the same issues, and I'll explain these in just a moment. So if I plug in f19 into my fourth root of 19 and then -3, I get the fourth root of 19 minus 3, which is 16. And 2 times 2 times 2 times 2, 2, 4, 8, 16. This simplifies down to 2. The fourth root is asking you what number times itself 4 times makes 16. And that's 2, 2, 2, 2, or 2, 4, 8, 16. Now, if I'm going to type in some other things too, you'll notice that for f, and typing in -13 here, if I put my -13 in for my problem here, you'll see that I have -13 minus 3. Now I have the fourth root of a -16. Now here's an interesting thing. We might have talked about this earlier, where if you have a negative inside of a square root, it's imaginary or impossible to do. Same thing happens for all even roots. Even roots cannot be negatives, so there's no solution here for this f typing in negative 13 in for your x. And the same thing will go with this next example here, because if I plug in my 1, I get the fourth root of 1 minus 3, or the fourth root of negative 2, and I really don't, at this stage, it's just no solution because you can't have a negative number in there. All right, and then finally, we're going to have our f of 84. We're going to plug in 84 in for my x. So this is going to give me the fourth root of 84 minus 3. And 84 minus 3 gives me the fourth root of 81. And can you think of a number multiplied by itself 4 times to get 81? It's not a big number if you need a hint. And the answer is 3. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So the answer to f of 84 is 3. All right. We're going to do some exponential fraction translation, which kind of pushes us a little bit into the next section here, but I think this would be the best time to talk about it here. Now see, this is technically the second root, which means it has an index. This is the number that's kind of in the crook of the square root symbol. This has an index of 2. And we usually don't write index of 2, but we'll just put it there for an example. Now, what this is telling me is that this has x to the 1/2 power. And if you have a graphing calculator, just try taking your graphing calculator and taking something that you know the square root of. Like, you know the square root of 25 is 5. So go to your graphing calculator and type in 25, the caret key, which is over the division key, and then parentheses 1 divided by 2. It really helps to kind of get into the use of using these parentheses. Though the newer graphing calculators kind of puts the 1/2 in the corner, and 0.5 would be acceptable. You can see that the 1/2 power gives you the same answer as the square root of 25. So 25 to the 1/2 power is the same thing as the square root of 25, which is 5. So likely this is going to be x to the 1/3 power, and this is going to be x to the 1/4 power. So this is going to be 32 to the 1/5 power, and you can try typing that into your calculator. Or just think to yourself, what number times itself would give yourself 32? Oddly enough, the answer is 2, because 2 times 2 times 2 times 2 times 2 is 32, or 2, 4, 8, 16, 32. So when we get to these interesting answers, you'll notice that this is x squared. Now again, I'm kind of pushing you a little bit here because this is x squared raised to the 1/2 power. According to our power rules, these two get multiplied. So 2 times 1/2 is 1, or 2 over 2 if you want to multiply top times top, bottom times bottom. But your answer is x, no matter how you simplify it. Again, to slow this down, I could have x squared times 1 over 2, which is x squared over 2, which is x to the 1 over 1, which is x to the 1, which is the same thing as x. So what x raised to the 3rd power would give me, or what x taken from the 3rd root will give you 1? Well, the answer is x cubed. So x cubed under the 3rd root radical is going to give us 1. And without giving the answer away this time, what will I put here under the 4th root radical to get me a 1? That would be x to the 4th, because the x to the 4th under the 4th root radical is going to be just 1. So what do you think the answer is going to be here? Will it be x to the 1/2, x to the 2nd power, x to the 15th power, or x to the 50th power? Which one of those seems to be right? It's easy to think it's going to be x to the 1/2 power, but actually the answer is x squared. Let's go through the explanation here. This is x to the 10th raised to the 1/5 power. Now, according to our power to a power rule, this would be top times top, bottom times bottom. And 10/5 is reducible down to 2. And we'll work more with that in the next section. So, just doing some quick simplification here, the square root of 25, again, let's assume that no nothing, no negatives have been raised to the positive root here, so we don't have to worry about plus or minus, nor do we have to worry about absolute value symbols. The square root of 25 is 5. The square root of x squared is x. Now here we have a negative 10x squared. Now, with a negative inside of the square root, we're going to have a little bit of a problem with that. So what this is going to be is an imaginary answer, and we'll talk more about this in a later section. But when we have a square root of a negative inside, we're just going to say no answer or no solutions. But that's just right now. We are going to be able to handle this by the end of the class here, because we will have situations where we can handle a negative inside of a square root, but we need a new number system to do that. Alright, so can you think of a number that's multiplied by itself 3 times to get to 64? That's right, the answer is 4. And since the negative's on the outside, we're just going to put that negative right in front. It's okay for negatives to be on the outside, but not on the inside of an even power. Alright, now in this case, we've got the 5th root of 7y to the 5th. Well, the 5th root of 7y to the 5th is, these are going to simplify because they're the same power and the same root. So I have 7y all normal without the 5th power, without the 5th root, but that negative still jumps right there like the other one did. Alright, now here's the chance. This is an index of 2. So what do you think the answer is going to be? Is it going to be 1/7, x to the 7th, x to the 16th? What's your guess? X to the 7th is your answer. And to slow that down a little bit, because we've got x to the 14th multiplied by 2 over 1, or sorry, 1 over 2. Sorry, I didn't mean to put that there. So top times top, bottom times bottom, 14 over 2 is x to the 7th. Alright, 2 more problems to go. Okay, for this last part here, we're going to take a look at even roots and odd roots and their domain. There are some restrictions. If your index is even, like square roots, 4th roots, 6th roots, 8th roots, then your x, or your domain, has to be greater than or equal to 0. Please don't worry about anything on the outside of your radical, because what you need to have is inside 5 minus 7x, that has to be greater than or equal to 0. So if I move the 7x, I got 5 is greater than or equal to 7x, and then divide both sides by 7. So 5/7 is greater than or equal to x, but we usually don't write it that way. We'll write it this way. X is less than or equal to 5/7. And that would have either set notation that looks like this, x, so that x is less than or equal to 5/7, a little callback to some previous chapters, or we can have it using parentheses. X will go from negative infinity all the way up to 5/7 and not include it. Now odd roots are great. Odd roots, if we have an index that's 3, 5, 7, and 9, and all the odd roots, the domain is going to be real. And the simple answer for that is because if we take if we take a look at x squared on a graph, what that will do is it will give us this. But if we take a look at the square root of x on a graph, well, flipping that over the y equals x line, this will give us this kind of curve like so, but it won't give us any of these down here. So this is why x can't be negative. Now on our root chart, looking at a x cubed, an x cubed is going to look like this. But when we look at the square root or cubic root of x, which is again flipped over the y equals x line, if you know your little geometry right there, what this will look like, it will look like this kind of line, like so. So we can actually have no restrictions on x. X can be positive or negative, where over here x could only be positive. There are no negative x values here, and there are positive and negative x values here on cubic roots and other odd roots to your problem. Well, thanks for watching.